Picture space as a vast, endless frontier, a dazzling canvas filled with twinkling stars, swirling galaxies, and secrets that have fascinated humans for ages. From enormous empty patches in the cosmos to the very moment time began, we can't help but wonder, does the universe have an edge, like a cosmic shoreline where everything stops? Or is there something incredible out there, hidden in mystery? Come along on an epic journey through the stars, where we'll explore what we can see, push against the limits of our view, and dare to dream about what might lie beyond the universe's edge. Look up at the night sky, and every star or galaxy you see is part of the observable universe, a giant bubble centered on Earth, holding everything whose light has reached us. This bubble is huge, stretching 46.5 billion light-years across, even though the universe is only 13.8 billion years old. How's that possible? It's because the universe is expanding, like a balloon getting bigger. As space stretches, light from faraway stars and galaxies travels a longer path to reach us, making our cosmic view much wider than the universe's age might suggest. This expansion makes it tricky to figure out where the universe ends. The observable universe includes everything we can detect, from the light bouncing off your bedroom wall to the faint glow of distant galaxies caught by giant telescopes. But what's past this limit? Is there a wall marking the end, or does the universe go on forever, its wonders hidden because light can only travel so fast? The idea of beyond sparks our curiosity, pushing us to question what we can't see and imagine what mysteries await. Our view of the cosmos is blocked by invisible barriers called cosmological horizons, shaped by how light and the universe's growth work together. The particle horizon is the farthest point from which light from the past can reach us today, setting the boundary of what we can observe. Beyond that is the event horizon, a line where anything happening now will never send light our way because the universe is expanding too fast. Then there's the Hubble horizon, roughly 14.5 billion light-years away, a distance that depends on a number called the Hubble constant, where galaxies are moving away from us as fast as light itself, making them impossible to see. These horizons act like a cosmic curtain, hiding what's beyond. The particle horizon grows as light from farther places reaches us over time, but anything past the event horizon is lost forever, its light stretched out of sight by the universe's expansion. Could there be stars, galaxies, or totally unknown things just out of reach? This question lights up our imagination, urging us to find ways to peek past these invisible walls. To understand where the universe came from and what its edges might be, let's look at the cosmic microwave background, CMB, a faint glow filling the entire sky. Found in 1965 by scientists Arno Penzias and Robert Wilson, the CMB is like a baby picture of the universe, showing the first light that shone 380,000 years after the Big Bang. Back then, the universe cooled enough for tiny particles, protons and electrons, to join into atoms, letting light travel freely. That light, stretched by the universe's growth, now reaches us as microwave radiation, visible in every direction at a distance of 13.8 billion light-years. The CMB is like a map of the universe's earliest days, showing tiny hot and cold spots that later grew into galaxies and stars. These patterns tell us the universe is flat, like a giant sheet, and reveal its makeup: about 27% dark matter, invisible stuff that pulls things together, 68% dark energy, a mysterious force pushing things apart, and just 5% regular matter, like stars and planets. The CMB also confirms the universe's age and its expansion speed, about 42 miles per hour for every 3.26 million light-years. But does the CMB give clues about what's beyond our view? Its sameness across the sky suggests the universe is similar everywhere, but it stops at our particle horizon, leaving us wondering, does it go on forever, or is it a doorway to something new? The universe's expansion, powered by dark energy, shapes how we think about its edges. Since the Big Bang, space itself has been stretching, pulling galaxies farther apart. It's not that galaxies are zooming through space, it's space itself growing, like dots on a balloon moving apart as it inflates. Dark energy speeds up this stretching, changing how we see the universe's boundaries. Galaxies beyond the Hubble horizon are moving away so fast their light can't reach us, cutting them off from our view. In 100 million years, this expansion will stretch the light from far-off galaxies like those in the CLJ 1001 cluster, making them fainter and harder to see with today's telescopes, though not totally gone. By 5 billion years, our Milky Way will crash into the Andromeda galaxy, forming a new, bigger galaxy, while others drift even farther away. This constant stretching raises a big question. If the universe is infinite, what's outside our observable bubble? And if it has an end, what's there? A wall, an empty space, or something we can't even imagine? Light can only show us so much, but other cosmic clues might help us peek past our horizons. Neutrinos, tiny particles that barely interact with anything, can zip across vast distances, carrying secrets from events like exploding stars or the hearts of galaxies. These ghostly particles could come from places beyond our particle horizon, and future detectors might catch them, revealing hints about the hidden cosmos. Then there are gravitational waves, ripples in space caused by huge events like black holes smashing together. In 2016, scientists at the LIGO Observatory caught waves from a black hole collision 1.3 billion light-years away. These waves travel at light speed and can bring information from places light can't reach, slipping past barriers that block regular light. As our tools get better, could neutrinos and gravitational waves show us a universe full of unseen wonders, or something completely strange? One of the universe's biggest puzzles is the Boötes Void, a massive empty region 330 million light-years wide, discovered in 1981 by astronomer Robert Kirshner. Found in the constellation Boötes, this void has only about 60 galaxies when we'd expect 10,000, making it like a cosmic desert. Its emptiness challenges the idea that the universe is the same everywhere. Some galaxies in the void form weird tube-like shapes, adding to the mystery. Voids like Boötes might have formed during cosmic inflation, a super-fast expansion right after the Big Bang, when tiny random changes left some areas with less stuff. Over billions of years, gravity pulled matter into denser spots, creating galaxies and leaving voids empty. Dark energy might have stretched these voids even bigger, pushing galaxies to their edges. Could the Boötes Void be a clue to something beyond our universe? Or is it just an empty patch in our cosmic neighborhood? It makes us wonder if voids mark the end of structure or hint at hidden realms. Another mystery is the Eridanus supervoid, a huge empty region about 1 billion light-years across. Some scientists think it might be linked to a strange cold spot in the CMB, where the temperature is lower than expected. They suggest this supervoid could cause the Sachs-Wolf effect, where light loses energy passing through it, creating the cold spot. But this idea isn't proven yet. There's also the Canes-Venatici supervoid, 1.2 billion light-years wide, showing how uneven the universe can be. These voids, part of a cosmic web of galaxies, clusters, and empty spaces, make us question what lies within or beyond these vast, empty zones. To imagine what's beyond the universe's edge, let's travel into its future, picturing how the cosmos might change over billions and trillions of years. In just 100 million years, the brightest, biggest stars will burn out, leaving glowing clouds called nebulae, while our sun gets a bit brighter, heating Earth by about 1%. Jump to 1 billion years, and the sun's heat will rise by 10%, baking Earth, stopping plant growth, and turning our world into a dry, lifeless desert. By 1.3 billion years, Earth's oceans will be gone, leaving only cracked, barren land. In about 7.5 billion years, the sun will balloon into a red giant, probably swallowing Earth in its fiery glow, before shrinking into a tiny white dwarf star by 10 billion years. Now, let's zoom way ahead to 100 trillion years. By then, all the stars in the universe will have flickered out, leaving the cosmos in deep darkness, with only faint glimmers from dying stars. At 10 quadrillion years, those white dwarfs will cool into black dwarfs, cold, dark husks of stars. If some theories are right, even the building blocks of matter, called protons, might break down, turning everything into tiny particles like neutrinos and photons. Black holes will also fade away, slowly dissolving through a process called Hawking radiation, leaving just a scattering of particles. What's the universe's final chapter? Several endings are possible. One is the heat death, where dark energy keeps stretching the universe, spreading everything so thin that no new stars or galaxies can form. The cosmos becomes a cold, empty place, too sparse for life or motion. Or there's the Big Rip, where dark energy gets so strong it rips apart galaxies, stars, and even atoms, shredding everything in a cosmic tear. But there's another path, the Big Crunch. If dark matter's pull beats dark energy, the universe could collapse in on itself, squeezing everything into a single, super dense point, maybe even kicking off a new Big Bang to start it all over again. Could these endings show us what's beyond? A big crunch, for example, might link our universe to a new one, hinting that the edge is just a doorway to another cosmic story. To really get what's at the universe's edge, we need to ask a wild question. What was there before the Big Bang? Let's explore some mind-blowing ideas, each offering a peek into the cosmic unknown. Picture our universe as one chapter in a never-ending book, part of an oscillating universe where the cosmos expands and collapses over and over. Each cycle starts with a Big Bang, grows, then crunches back into a tiny point, only to explode into a new universe, a cosmic loop of birth and rebirth that goes on forever. Or maybe our universe isn't alone. The multiverse theory imagines tons of universes, each with its own rules, like different games with different rulebooks. Our Big Bang might have happened when two universes bumped into each other, suggesting that beyond our cosmos is another universe, full of strange wonders we can't even dream of. Another idea, from scientists Stephen Hawking and James Hartley, is the no-boundary model. They picture our universe as a finite bubble with no edges, like a 3D version of Earth's surface. In this view, the Big Bang is a smooth starting point, and asking what came before is like asking what's north of the North Pole. It just doesn't make sense. Then there's string theory, with its ekpyrotic model. Imagine our universe born from a clash of giant, invisible sheets called brains, floating in a higher dimensional space. This crash could have sparked the Big Bang, hinting that beyond our universe lies a bigger, stranger cosmos. The vacuum fluctuation model offers another twist. Our universe might have popped out of a tiny bubble in a quantum vacuum, where particles appear and vanish randomly. One of these bubbles could have ballooned into our entire universe, born from a spark of quantum chaos. Lastly, there's the Big Bounce theory, based on a field called loop quantum cosmology. Instead of starting with a Big Bang, picture a previous universe shrinking down to a super tiny point, then bouncing back to expand into ours, dodging a total collapse with quantum magic. This suggests an eternal cosmos, where the edge might be a bridge to an earlier universe. These ideas, while unproven, make us think the universe's edges, whether in space or time, aren't walls but pathways to something bigger, woven from cycles, collisions, or quantum sparks. Dark matter and dark energy make up about 95% of the universe and shape its story. Dark matter, invisible but heavy with gravity, acts like a cosmic glue, holding galaxies together and forming the web of the universe. Dark energy, a mysterious force, pushes the universe to expand faster, maybe even making voids bigger and galaxies lonelier. Their tug of war decides if the universe keeps growing or collapses. Could dark energy connect to something beyond our universe? Or does dark matter hold hidden structures we can't see? These mysteries keep scientists searching for answers. The multiverse idea suggests voids like Buddhas might be doorways to other universes. In string theory, these empty patches could thin the fabric of our 3D reality, maybe showing hints of other dimensions. Or perhaps voids hide primordial black holes, ancient black holes from the early universe that cleared out their surroundings. These ideas aren't proven, but they make voids more than just empty spaces. They're like cosmic labs for testing wild theories about reality. Our curiosity drives us to explore the unknown. From the first telescopes to modern projects like the Sloan Digital Sky Survey, we've mapped the universe's web, spotting voids and galaxy clusters. Future tools like super-sensitive neutrino detectors or observatories for gravitational waves might reveal secrets beyond our horizons. Ideas like Dyson spheres, giant structures to capture star energy, or settling on other planets could help us see farther. But the universe has limits. In tens of billions of years, expanding horizons might block out distant galaxies, isolating us. Still, every discovery, a void, a wave, or a CMB flicker brings us closer to understanding the cosmos and its mysterious edges. So, what's beyond the universe's edge? An endless stretch of space, a multiverse of strange realities, or a new cosmic cycle? Our observable universe, limited by light and expansion, shows us just a piece of the puzzle. Horizons, the CMB, and voids like Boötes hint at a wild, complex cosmos, while neutrinos and gravitational waves tease glimpses of the unseen. Ideas about what came before the Big Bang, cycles, collisions, or quantum bubbles suggest the edge might be a gateway to new beginnings. As we stare into the cosmic unknown, the universe's greatest gift is its mystery, inviting us to keep exploring, questioning, and dreaming about the wonders beyond.